notes, please do refer to second unit 7, properties of matter, and the chapter is elasticity. The first topic which I am going to talk about is deforming force. The first one is deforming force. Now, it means by the topic itself is force. Means by the external force which when applied to a body causes any change in its size or shape or both, and the force is called deforming force. Now, if you apply some force to a matter, okay, this chapter we are studying about matter, and this chapter is basically about solids. So, if you apply a force to solid, suppose if you apply to force a piece of chalk, then what happens? The shape of the chalk and the size of the chalk both will change. So, that particular force which changes the shape and the size of a particle object is known as deforming force. Now, with that, our next topic is elasticity. When an external force is applied upon a body, then there is a change in either shape or either size or both. That force is deforming force. Now, on removing it, after applying the force, the shape is changed. On removing it, what happens? Some of the body again acquire their initial position or initial shape, original shape and size, and that property of recovering its shape and size is called elasticity. Suppose for a rubber band, if you stretch a rubber band, what happens? After removing the force, it will come back to its original shape and size. Now, some objects such as, say, piece of chalk, clay, for example, if you change the shape, then what happens? It cannot come back to its original form, original shape. The property of that object to regain its original shape and size is known as elasticity. And the body in which this property is found is called elastic. By definition, elasticity is that property of a material of a body by virtue by which the body opposes any change in its shape or size when deforming force are applied to it. So, elasticity is actually a property of any body. Suppose for this object. Okay, it's a property of that which do not allow external force or deforming force to act upon this, or deforming force to change the shape and size of the body. So it is a property which will not allow the external force to change this shape or size of that body. That is known as elasticity. So when on removing the deforming force, what happens? It will still remain as it is. So there are few topics such as under elasticity, one body is elastic. Okay? Now, what kind of a body is elastic? Elastic is those type of a material which can restore its shape. Okay? The bodies which recover completely their original state on the removal of the deforming force are called perfectly elastic. So, which can restore the shape and size, which can easily come back to its initial shape and size. Those bodies are known as elastic by nature. There is another type of a body which is known as plastic. Okay, now plastic means those bodies which do not recover their original state when deforming forces are removed but retain their modified form. So, when on changing the shape, for example, clay. You take an example of clay. You give new shape to a clay, it takes a new form. So, it cannot go back to its initial form or original form. material are known as plastic, which cannot restore the shape. Okay, those are known as plastics. There is another type of material known as rigid body. Now, however, if on applying external force on a body, the relative position of the particles of the body do not change. That is, there is no change in the shape, no change in the size. Those type of bodies are known as rigid body. For example, take for example diamonds. Diamonds are very hard to break. So those type of a body which do not easily change their shape are known as rigid body. But there is no perfectly rigid body. There is no perfectly plastic body, or there is no perfect elastic. There is some flaws in every type of material. Even every rigid body can be broken into pieces, but they can at least they can stay away, or they can protect themselves for lesser amount of force or deforming force. So if more amount of deforming force is applied, then only it will change its shape. But if the force is less, then it will not easily change its shape. So with that, we'll talk about limit of elasticity. Limit of elasticity. Now, when we apply a force, what happens? Some object will easily change its shape. For example, elastic. It will change its shape, but it will come back to its original position. Plastic. It will easily change. We can easily change the shape, but it will not regain its initial position or original shape. Then comes rigid body, where we cannot change the shape or size at all. Those bodies are known as rigid body. Now, maximum deforming force up to which a body retains its property of elasticity. That means a force when applied, maximum deforming force up to which a body retains its property of elasticity. It means that if we go on increasing the deforming force, then a stage will be reached when on removing the force, the body will not return to its original state. Okay? For example, if you stretch a rubber band, what happens? At a certain point, the rubber band will not come back to its original shape, but instead it will break. So there is a limit for elasticity. So the maximum deforming force, when not applied, the object can return to its initial original shape. That is known as elasticity, or the limit of elasticity. Okay. Now, we'll talk about two more topics. That is strain and stress. First one is stress. Now, when an external force is applied upon a body changes its shape or size, then what happens is, then at each cross section of a body, an internal reactionary force is developed. So if I am applying some force in an object, if I am trying to break it, an internal reactionary force is developed in that object in the direction opposite to the applied force, which tends to restore its original state. So the internal restoring force acting per unit area, okay? The internal restoring force, which actually tends to reform its original position. Okay? If you apply a force, there will be an opposite force to which I am applying. So that is known as internal restoring force. So internal restoring force per unit area. Restoring force per area is your stress. This internal restoring force actually it increases depending upon how much external force we are applying. So if you increase the external force, the internal force will also increase. That is how we can calculate the stress developed in any material. So if I apply pressure to an object, a material, stress will be developed. What is that stress? It is actually a force which is getting developed inside the body to oppose the external force. Okay? So the force developed inside the body divided by the area is the stress. Now the unit of stress is force is Newton, area is Newton. So the unit is Newton per meter square. Next term, strain. Now, when we apply some external force, what happens? The size and shape will be changed. The change occurred in a body is known as strain. Okay? The change occurred in a unit size of a body is called strain. It is the ratio of actual length to increasing length. I'll just give you the formula of strain. Strain actually is different on different types of objects. Suppose if it is a wire, if I apply some force in a wire, what happens? It will change, the length will increase. The length of the wire will increase. So what we can say is, initially whatever length is there, divided by whatever length is increased divided by whatever total length is there, gives you the change in the length. So that change in an object is known as strain. So if there is a balloon, if I remove the air from the balloon, then the size will change. The change in size is actually the strain. So it is different on different objects. So it doesn't have a specific formula. It depends on what type of object and what type of force are we applying. So this is the amount of change occurs in a body. This is a ratio. Okay, ratio, that means change is a ratio. That is why it doesn't have any unit. And the last formula which I am going to give you today is Hooke's law. All this topic we are doing for the first time because this is not that in unit classes, but I will study over here and just to continue in bad classes. Another one is Hooke's law. Hooke's law is nothing but a ratio. Hooke's law is it is a ratio of stress divided by strain. It is a ratio of stress divided by strain. So it was experimentally shown by Hooke in the year 1679 that if strain is small, if the internal restoring force per unit area is small, then what happens? The stress is proportional to the strain. So the stress will be automatically proportional to the strain. So the change in the object is automatically proportional to the internal force. The value of modulus of elasticity of a material depends upon the type of stress and strain produced. If strain is longitudinal, then the modulus of elasticity is called Young's modulus. If the strain is in a volume, then it is bulk modulus. And if strain is shearing, then it is called modulus of rigidity. All these different types of modulus we'll study in the next class. Okay, this is just a basic idea of what we are going to study. So please go through your book. If you have any doubt, please do ask. Okay, this much for today. We'll continue in the next class.